Hey everyone, lesson 6.6, equations for lines through 2 points. Today, after today's lesson, notes on your own and then the in-class stuff, you should be able to give the equation for a line, given any 2 points on that line. And also we are going to continue to connect linear situations to a real world scenarios. Taking a look, today we're not going to really learn any new concepts. We are going to make use of a couple things that we've done in the chapter, specifically in lesson 6.2 where we calculated the slope given 2 points, and specifically lesson 6.5 where we gave an equation for the line given a slope and a point, the slope, point-slope form of a line. So what do? If we've been given 2 points, the first thing that we do is to use the 2 points to find the slope of the line. Making use of our formula, slope is equal to y2 minus y1 over x2 minus x1, the change in y over the change in x. I have seen a few people reversing it. It does have to be the change in y, numerator, and the change in x in the denominator. The second step would be to use the point-slope form for a line to substitute the values. Again, point-slope form of a line says y minus k equals m times the quantity x minus h, where m is the slope of the line and hk is any point on the line. H is obviously the x-coordinate, k is obviously the y-coordinate based on the way it is set up. And then give the equation in the desired form. Remember, slope-intercept form, where we see y equals, is the most beneficial for graphing purposes. So taking a look, find an equation for the line that passes through the points 7, negative 2, and negative 5, 4. Give the equation in slope-intercept form. First, we would need to calculate the slope. Again, using our formula for slope. You can see that the order that I decided to use was 4 minus negative 2 for my y's. So that locked in that order for the x's as negative 5 minus 7. If we calculate that out, we could then substitute everything that we know in slope-intercept form. As we calculate out the slope, 4 minus negative 2 over negative 5 minus 7, we do arrive at a slope of negative 1/2. We've used the point 7, negative 2, entered y minus negative 2 equals negative 1/2 for our slope from right here, and x minus 7. We would then solve for y to get this equation in slope-intercept form. Since there would be simplified, it would come out to be y equals negative 1/2 x plus 1.5. So this is an example of how we can take any 2 points and write an equation for the line. We first use the 2 points to find the slope of the line, calculating our change in y over our change in x as we began to do in lesson 6.2. We would then use this point-slope form that we talked about in lesson 6.5, using the slope and either of the 2 points to enter in to get the equation for the line. And then we would go ahead and give the equation in the desired form. A real-world scenario, Tracy is very upset. She wanted to go swimming. The pool was only partially filled when she got there. She immediately began filling the pool with a hose, but it seemed to be taking forever. So she decided that she was going to practice some algebra. Hard to believe, I know. So about 30 minutes in, she saw that the water level was at 3.5 feet. After another 45 minutes had passed, she noticed that the pool was at 4.25 feet. So now she's going to find an equation that would tell her how fast the pool was filling, what the water level was when she started filling, and when it would finally be done. I want you to go ahead and help her. The hint that I have for you as you take a look at this, and we will I guess take a look at this in class a little bit. In this situation, the independent, or the x, is the time spent filling, and the dependent, y, is how high the water is. So we actually have 2 ordered pairs that we can find. Knowing that the time spent filling relates to the water level here, we have 1 ordered pair right here with 30, 3.5, and another ordered pair with 45, 4.25. Using those 2 ordered pairs, we should be able to come up for an equation of a line that would answer the questions, how fast the pool is filling and what was the water level when she started. And using that equation, we can answer, when is this pool finally going to be filled? When will it be 6 feet deep? So tackle this on your own. We'll continue looking at it when we come to class together, using your ideas. We'll probably add in another example or two, so go ahead and save some room.